Hello everyone and welcome. So in this video I'm going to show you step by step how you can create a procedural roof like this one. Let's get started. So let's start by dropping a geometry node, and we will use a grid. Let's set the dimensions to something like 16 and 12. You can change this later. And let's see, rows and columns to 3 to have this center point, and the connectivity we can set it to alternating triangles to have that roof shape. Now we can transform the center point, so for that let's group, and we can do bounding regions and points, and that already gives us the result we want. And let's now transform it up. So let's raise it, the center point, something like 3 in the translate y. Now we don't need these edges in here, these middle edges, so let's blast them or dissolve. So we can just use dissolve flat edges. Now let's see our normals. We might want to add some hard normals to harden the geometry, so let's go with vertices and set it to 0, the cusp angle. So now that is more likely, because we will copy a few grids to this that can be used to instance our geometry, our tiles. So now let's extract the centroid to copy the geometry to here. Let's go to primitives, and we lose our normals, so let's go to an attribute promote and promote from vertex to primitive, and let's go with normal, and we should have our normal. We just need to set transfer attributes to normal. This should do the trick. Now let's copy the geometry. So creating a grid can be on the XZ plane, there's no problem. And we can copy the points. And this will give us this result, which is not ideal, it's not what we want. We want them to be flat on these planes of the roof. So we can change the orientation and whatnot and create the up attribute, but let's do it the hard way, let's say, so we can learn something new. So creating an attribute wrangle to do some basic vex. So the first thing we want to do is to create the up attribute. So we'll set it on the Y. And that already gets some orientation going. And let's also give some aspect ratio, a different aspect ratio to the grid, so we can know if it's oriented correctly. So in the attribute wrangle, let's create, let's see the normals. So right now, let me just change visual guides scale normal to 1. So our normals are pointing like this. Let's create an out attribute, so we can then use it to create another one, which will be the sides, and then we can orient the planes properly. Let's go one by one. So let's go to v at out. It will be equal to, let's normalize it, and let's subtract the position from the middle points, but on the y plane of the points. So let's go 0, 0, 0, but in the y, let's create, let's say, at p dot y. So let's see that out attribute, and let's control click it and say it's a marker vector. Let's say is blue. In blue you can see it, so let's keep it yellow. So now we have this one going out, and let's create the side one because we will need it. So let's go with v at side is equal to cross, and let's cross the out and the n. Okay, let's see the side, and let's again edit it to a vector. Let's say this one is red. So now we have the side attributes, and finally we can say v at n, let's edit our normals and cross between the n and the side. And now our normals should be pointing like this along the geometry, along these triangles. Let's get rid of the visualization and the normals, and let's see. So now everything should be working as expected, as we have our geometry and the planes are oriented correctly. So that should do the trick. Now we need to create the proper size for the planes. We will need to fit these grids to the original roof geometry. So for that we will need to calculate the width of these prims. So let's go in here and first create a measure. So let's move this up and create a measure. We will need the area. So let's go with area, per element is fine, and area. And now in a wrangle we will calculate the width and the height. So for that, let's go over primitives and say create the bounding box, not attribute, but let's keep it in a variable, get bounding box size. So we get the size of the prims. And now we will need a different widths and heights for each prim, so we need to somehow filter through them. So some primitives, the primitives that are facing the z-axis need to be different from the prims facing the x-axis. So what we can do is to use the normals. So if we say if absolute v at n dot x is smaller than 0.001, we can set the width attribute f at width is equal to bounding box dot x. So in this case, for these primitives, we will measure the x size of the bounding box, and for the other ones we will measure the z size. So now we can just say else width width will be the bounding box dot z. And for the height, I just found a formula online that you can take 2 times the area and divide it by the width. This is the formula for the heights, as far as I know. So now we need to use per point attribute, so we will need to loop. So for each point we will need to use the copy to points in a loop. And now we can set the attributes on the grid. So we need the width and the height. So for the width, let's say points, and we will reference the for each begin. So for each begin one, and we will need the point 0, let's say, and get the width, and the index is a float, so it's the default one. Now this is turning out 0, we need to promote it in here, the width and the height. In this case something is wrong, so let's see. Read. So I believe I have something wrong in here. Let's see. Oh, we need to actually, it didn't throw an error, so now this should do the trick. Let's see. Not yet. I mean, I'm not sure if it's, let me see. So this is actually correct, the width is working, we just need to set the height. So let's go to the grids and copy this expression, and let's go for height. And let's see, in the, this is also correct, but we need to set the centroid to be bounding box center. Now this should do the trick. Let's also create an attribute in here. So let's go after this one. Let's create an attribute triangle and just say that have a string attribute, let's say prim id will be equal to I to a, so integer to string, and let's say prim num. So for each prim it will create an attribute, so let's say primitives, and in here we should have a prim id with, in this case it's numbers, but it's a string attribute. Alright, so we have it working. Let's continue. Now we need to set the density, so the rows and columns. So for that, let's create two attributes, two float attributes. So in this case, let's say it's density rows, and float. Let's apply, let's Control C, Control V, and density calls for columns. So now we have these two attributes, and we can take for the rows will be the density y, let's say. So let's copy the y component of the size and paste it in here. And now we can say 1 and copy this and multiply it with the density. So we can just have a multiplier. Let's set this to 1 and let's copy the x, or let's just copy this expression, paste it and say x and calls. So this way we can set this 1 and 1 and we will have the squared out divisions, but we don't want them squared. I have some values here, 1.6 and 2.5, but you can play with it. So this way when we copy the tiles to the centroid of the prim, they will be equally distributed both on the x and the z. So now we need to get rid of these extra shapes that we don't need. We won't need tiles in here, but we should leave at least some room so it fits perfectly on the edges. So for it will make more sense later on, but for now let's just object merge the, so where, let's say in here, we can create a node in here, and let's say it's roof base. Let's copy it to here, create a thicken. We can actually first, let's group and say it's points and keep by bounding regions and bounding objects. And as you can see, that won't work. We will need to add a thicken, so let's say both directions. And it's not selecting the corner points because it's right on the edge. So what we can do is just create a transform and make sure it's in the center. So centroid the x, the y and the z, and let's go for 0.01 just to select the corner points. Now we can leave some room to make sure the tiles fit perfectly. So for that we can create a group expand, and let's say group 2, and 1 is fine. We will have some extra room so we can cut them later. And from here let's blast non-selected, and let's say group 2. So now we have this. We have some extra room to play with. Now I will paste in here just the tile model. It's nothing complicated. I just did it with a few extrusions and bevels. So as you can see, it's pretty simple. Just to speed up. And let's create a copy to points. And we will need to extract the centroid. Extract centroid. And let's go with primitives. And let's copy this to here. And right now it's just too big, so let's create an attribute create. And let's say p-scale 0.15. And we will also need normals. So after the blast, we will need to add a normal, and let's say primitives, and in the extract centroid transfer the normal, and let's also rotate these 90 degrees, and we will need also an up attribute. So in the same attribute create, let's go with another one and say up, and this one needs to be a vector and say 1. So now that it's working properly, and we will also need for later the prim ID, so we still have it here. No, let me see. Prim ID, where did I lost it? Oh, in here. So we need to send the prim ID. We still have it, and it's right here that we lose it. So let's make sure we promote it from point to primitive and prim ID, and in here we pass it to prim ID. So there you go, and let's see that attribute and make sure it is set to color and random from attribute. And we have the ID for each section that we will need for the Boolean. In this case we won't use Boolean, we will use another technique that is more efficient or faster. So in this case I don't want them rotated exactly 90 degrees. So let's say it's 85 to have that typical tiling effect on top of each other. So that is fine. And again, we have the prim ID as a point attribute because we extracted the centroids. So let's promote it back to prim. So from point to primitive and prim ID. And now we will cut the extra geometry. So for that, let's create a for each loop so we can iterate over each piece to cut it. So let's go with the for each named primitive, and let's say prim ID. This should work fine. Yeah, if we go with a single pass. And now we can use booleans, but again it will be a bit slow, at least on my machine it's a bit slow. So I found another solution which will be using the clip nodes with the proper orientation that we can extract from the normals, let's say. So let's try that. Let's copy this object merge and create the meta import. Let's call it meta, because we will need the iteration. Let's paste here. And let's blast. Let's blast the primitives. So let's go with the detail we will just extract one primitive at a time. So let's go with, let me check, do we have the prim ID in here? No, so we need to change this roof base to be in here. Does that messes up? No. So yeah. So let's say this will be at prim ID will be equal to prim ID. Prim ID will be equal to detail, and we will use iteration, and index 0, and in here we will use -1 for a spare input. So let's create that, add spare input, and we will connect the meta nodes. So let's see. Let's forget that for now. Actually, we will need to delete non-selected. So if we do this, we have this one, and if we go for the single pass 2, we have this one, so it's working. And now, having this, we can create some normals to extract these points, these edges, so we can use it for cutting our geometry. So let's go with the polyframe, and let's say the tangent name will be n. So we have them like this, and now we can just group it. So let's go with group and say edges, and keep binormals 1. Let's go -1, and this should do the trick. Now we can just convert it to curves. Let's group to curve, group 3. From here we can, as you can see, this is this is a single primitive, so a single curve. So what we can do is to cut it, so polycut, and let's say cut and cut points all. Now if we do an exploded view, we have to separate geometries. Let's now see how we do this. So let's split, and let's split primitive 0, and we can create a wrangle and copy this one in here. So what we can do is, first of all, we will need to orientate first the two curves. So let's do orient along curve. So orient along curve after the cut, and we need to set it to points, and we need x-axis, so let's go again. We might need to reverse this, let me see. We need them pointing outwards. Let's see if we reverse in here. Now it's working properly. So now we, in a clip, we can set the direction. So let's say 1. We can set the direction. Not here, let me see. As you can see, we can set the duration, and that's what we're going to use to cut the corners. So let's create the direction attribute. So, and we will need 2 clips, one for the left and one for the right. So direction 1 will be point, and input 1 and 0. And let's do the direction 2 too. Direction 2 will be input 2 and the normal. So in here we will connect the input 2 to the 2, so 0, 1, 2. And in the clip, now we can set the first direction. So in the clip, let's go with point. And let's use spare input -1, because we will compile this. And direction 1 and 0. And let's add the spare input. So add spare input. Let's connect this. So index 0, component 1, and component 2. So we might need to change these primitives below the plane. So now we just created the cut on the right, and let's create another clip. Just copy this one, and we can set the spare input to the above node. And now let's say direction 2, direction 2, and direction 2, and that should do the trick. Now hopefully we should have everything working. Let's see. Let's change the single pass, and it works on all the prims but one, because the normals are inverted. So in here we need to check which, so is the single pass 1, so the pass 1, and for that we can just get rid of the reverse. So let's create a switch and use the reverse, and use not the reverse in the second input. Let's say detail, let's use the iteration. So we can just create a spare input and connect the metadata node, and let's say detail -1 iteration 0 is equal to 1. So that should do the trick. Let's remove the single pass, and there we have it, everything cut perfectly. Now we can just compile this. So let's create a compile block Let's add it in here and in here. Let's say multi-threaded. And this should do the trick. Let's just see. It's mostly just warnings that we don't need to pay attention. So from here I'm just gonna show you what I've done. So let me just copy from here. Oops. Oh, in the object merge we need to make sure we use this one. And the same in here. No, this one is fine. So I just copied a few tiles in here, pretty easy. Just create the curves and a few attributes, the up attribute, get rid of the middle ones, create a p-scale attribute, and we have another model of a tile. You can get this on my Patreon, the project file. And in here I'm just creating two different tiles oriented and slightly bended, and then add a boolean at the end to unify everything. Not perfect, but that should work. I'm just doing this now because it's already a very long video and I don't want to bother you anymore. So you can grab the files on my Patreon if you want to and explore it on your own. So I just want to mention that I just created a new course called Roman Bridge Procedural Asset Creation, and I also have another modeling course. You can check those out. So I have this one, that is the old course, not very old, it's still on Houdini 19.5. And I have this new course that I just created, that I believe it might interest you if you want to dive into proceduralism. So that's basically it. If you guys want the project files, just check my Patreon, I will be uploading to there. And I hope that you have learned something new today. Thank you and see you next time.